Good morning, good afternoon, depending on where you are in the world. My name is Luke Hines. Nobody would know me as yet. I've recently started doing content, and I'm a software engineer. I've been a software engineer for about 20 years now, predominantly working in open source. Luckily, I've had a career that's really allowed me to do a lot of open source work. Sort of security is my area of specialism or focus over the years. I was a distinguished engineer at Red Hat. That's sort of where my career was last situated within a big company. After that, I've been part of startups. Recently, a CTO at a software supply chain startup, and a startup that started looking at AI recently called Stacklock. And yeah, I have had, as I say, a long career. I don't think it's because I'm particularly clever. I think it's because I'm persistent and I love technology. So, I mean, I may well do a video about my career, really, and, with the view of that being useful to others and, how you can grow your own career. And open source has served me very well over the years. So anyhow, let's get on to topic. So I have this plan of every Friday pulling out a somewhat random thread from Reddit, particularly on the local llama community, but we might look at others. I do like local llama. It's a great place to get up to speed on the latest models that are happening, various sort of industry news. It's a really good source. And so I've pulled out this thread, which was particularly interesting. And it's almost going to sound like I'm, what's the word, astroturfing. I promise I'm not. This is not a kind of an account that I own, right? But it's a topic area that I've worked in fairly recently. So I thought this would make an interesting one. So let's delve into this. So the future of AI won't be cloud first. It will be chain native. Okay, interesting. So, and thank you, Maleficent Apple 287 for your thread. So AI is grown up inside centralized clouds. Centralized clouds. Okay, well, let's come back to that. Fast, convenient, but tightly controlled. Okay, so I'm assuming they're referring to the sort of predominant large big tech clouds such as Google Cloud, Azure, AWS, and so forth. The problem, as AI becomes more powerful and influential, questions around transparency, ownership, and control are only getting louder. I agree. I absolutely agree. So cloud-first AI can't answer those questions. All right, let's see. Okay, so chain native AI can. Okay, so the shift isn't just about putting models on a blockchain. It's about redesigning the whole system, how models are trained, verified, shared, and rewarded. Okay, so let's dig into rewarded. That would be interesting. So in a way that's open, trustless, and community-driven. Amen. So think about it. Training data provenance logged on chain, community-led governance over AI behavior, fair rewards for contributors and validators. Okay. Verifiable inference, not black box outputs. Okay, interesting. User-owned data powering user-aligned models. All right, let's get through this. You don't want to just watch a video of me reading out a blog piece, a Reddit post rather. Instead of closed APIs and hidden models, we get AI that's accountable and modular, built on Rails that anyone can audit or improve. It's early, but the foundation is forming. The tools are coming together, and most people won't even notice until it's already everywhere, just like the internet itself. The next generation of AI won't live behind a paywall or someone else's cloud. It'll live on networks we all share, shape, and secure together. So I guess they're referring to some sort of peer-to-peer shared sort of kind of like a community clustered inference or something. There's no links here. It's mentioning a foundation and events are on the way, but I don't see any links or further reading material. But let's dig into this. So this is particularly interesting because I started a project back in 2020 called SigStore. And SigStore was focused on software supply chain security, predominantly open source packages. They lacked a credible level of provenance to be able to, for you to perform attestations that the integrity of that package had been maintained from the source code to the built package that you imported into your code, whether that be a kind of like some sort of a tarball, like a wheel file, or a compiled blob perhaps, or something that's compiled to blob, in regards to Rust and Go and so forth. But there was this sort of kind of a table to mill level of provenance that was missing. So Sigstore really was around, first of all, getting people to sign, so cryptographically sign packages, okay, and then being able to have a sort of a transparent, auditable record of those signing events. And so within Sigstore, we use this technology called a transparency log, which is pretty similar to a blockchain, but it doesn't have a distributed nature. But they both use something called a Merkle tree. So Merkle trees are pretty interesting. They are effectively hashes that are concatenated together. So you have these, if anybody's aware of a hash, a digest, typically they have names MD5, SHA-256, 512, okay, and effectively a number is generated, a fingerprint around an artifact, okay, and then if you change any little bits or bytes of that artifact, the digest will change, okay, this sort of cryptographic, well, it's not cryptographic, but this sort of computational number is generated that's specific. It's a fingerprint that's specific to that particular artifact, and then these are concatenated together, which means you take one and you put it next to another, and then you generate a digest of that, and you keep going up a tree until you eventually end up at a kind of a root hash, effectively. And any of those small little individual tree elements, these hashes that change, will change the root hash, effectively. And these originally saw a lot of use in the wild with peer-to-peer networks, especially BitTorrent, which still uses a Merkle tree. So the idea is all of these files that were distributed and shared around, each one would have a digest, okay? And then as you receive these digests, so as you got a file part of starwars.avi, you would compute the hash, and then you'd kind of calculate this Merkle tree up to the top, and you would make sure it looks the same as what everybody else has seen. So that way you knew somebody didn't tamper with an individual file part, okay? And blockchain uses a similar thing in a way for sort of transaction signing and how the blockchain is constructed. There are different types of trees now, like sparse Merkle trees, I think Ethereum and others are using. But anyhow, I digress. We had this transparency log, which we use for being able to have a sort of a public, auditable, transparent, immutable record of signing events. So anybody could go in and sort of challenge this log, because it was cryptographically there to be monitored, and you could compute the proofs effectively to see if you ended up at the same root hash. There's a bit more to it involved than that, but that's it generally. And the project, I think it was about a year ago, somebody worked on it. They started doing this for model provenance, okay. So the idea is that a model, if you look at its kind of constituent parts, you have the data set effectively, and and that's the kind of real crux of it, really, because that's your information, which is these things can be huge. This is where basically you're scraping the entire internet and academic papers, and a big chunk of data is sort of a serialized, canonicalized, got into a format that's suitable for training, okay, and then a model is trained. A model is trained on that with different sort of training mechanisms, lots of different approaches that are there now, and you then end up with a model, which is a kind of, generally it's a group of tensor files. People predominantly use safe tensors now, and perhaps like some JSON to tell you about the configuration of the model, and various other little sort of files and so forth. And this is your large language model, okay? And then that is obviously brought up for inference with using something like VLLM or a Llama, or Hugging Face Transformers has a library to run a model as available for inference. And then typically an API is put on top of that, a REST API, so that you can then call the model in the way that you would traditionally call an API effectively. You know, there'll be some text and some parameters like the temperature and so forth, and then you get back an output. And so let me just think where I was heading with all of that. So yeah, so that is kind of, I guess, this sort of, you know, this what they're talking about here really is this provenance is logged on chain. Okay, and I really agree. This is the right way to do things. You should be able to have another concept that you'll come across quite a lot in sort of build environments and software and so forth is reproducible builds. Okay, so, you know, I take the source code, I take some of the inputs, the compiler, semantics, flags, so forth, and I build them. I build a piece of software, and then I end up with an identical piece of software to everybody else. So that suggests that somebody hasn't tampered with the constituent parts that are used to create a compiled or built piece of software effectively. And that's what this is heading to do. Is you can, I mean, okay, there's a few other things to this. The data has to be, you know, the data set that's used has to be open. Okay, and a lot of the frontier models are not going to do that because it's against their business model. You know, it's you know, they obviously spent a lot of time and money you know, creating this data set into a format that's sufficient for training, and, you know, it's probably been human reviewed, you know, and sort of cleaned and so forth. So they're not going to give this away, unfortunately. You know, hopefully we will live in a world where eventually data sets are open, and then once we do, we then have a position where you could effectively have a model, okay, and that model is fully accountable. Okay, it's fully transparent. You know precisely the inputs, even though it might be vast a lot. You can effectively know what went into that model. Okay, and this is really important because models are, you know, you can derive knowledge from a model. Okay, so what am I talking about here? I could ask about the political history of a country, or, you know, religious beliefs, or, you know, cultural questions, technology questions. I could ask an LLM to generate code, okay, and then really, you know, the answers are contingent upon the quality of the data that was used to train that model effectively. So if a model is in some way that, you know, the data is compromised or in some way sort of tailored to promote outputs that are perhaps more suspicious, malicious, maligned, okay, that is a problem. You know, there could be, you know, you could train a model to occasionally surface some vulnerability. You know, there could be a case where a model under certain conditions could provide a slightly sort of biased political opinion. Okay, I think this gets really important with where advertising is going to be a key element of large language models. You know, the product placement and these sorts of things, and that's where this really becomes important. So I very much agree with you, Maleficent Apple 287. I think the only things I'm kind of not entirely sure about is they mentioned somewhere rewards, like fair rewards. Okay, and this is a challenging one with any sort of reward system around contributions and so forth, because people will try to game it. Okay, this happens a lot. There was some folks that I worked with. They developed something called a T protocol. Okay, and the idea was that open source developers that had popular packages would be rewarded by this tree protocol, which was using some sort of cryptocurrency, and they effectively built a graph of you know, what packages were widely used in other packages. Okay, and then, you know, some folks realized, well, what we can do is we can just create thousands of spam packages that all link to each other, or they perhaps link to one popular one. Okay, and then that's the one that gets the reward. So it's always very difficult, this sort of reward system. It's something that people have been trying to crack for quite a while, is how do we fairly reward open source contributors for the time that they've put into their projects. You know, a lot of the time these people are doing this on a sort of voluntary basis. You know, they're unpaid. And so, you know, to summarize, I really agree with this. It's the chef's kiss of where we should get to with large language models, where they're open, transparent, accountable, very, very important because these models are going to become so central to political information, financial information, cultural information, a whole spectrum of things, a whole spectrum of different areas. So I am exploring this space. So I'd be happy to chat to you, Maleficent Apple, or anyone else. If you would like some links, this is the project that I referred to earlier, Sigstore. So we've actually got a page here, and you can reach the GitHub from here. And there should be, if I come across to repositories, model provenance, excuse me, provenance, okay. Oh gosh, how embarrassing, provenance. All right, let's just try model. Never work with animals or people that are slightly dyslexic. Here we go, model transparency. So supply chain security for ML. Yeah, and this is pretty much kind of what was being suggested around the on-chain protocol. Okay, so yeah, dig into this, have a look. And I'm sure there are other efforts out there. Something recently that I looked at doing is more on the identity side. It's a project, a kind of prototype that I worked on. And but yeah, I'm kind of probably been going on a little bit longer than I wanted to. Let me know if this is any good, if this is useful. You know, if I should do more of these. You know, obviously, if it's not really of value to others, it's probably not worth me putting my time in. But if it is valuable, do let me know, and I'll do more content like this. And so, yeah, I'll post this up and look forward to getting some feedback and seeing where this is going. And just last of all, you know, if you have any links around a foundation or some efforts, I'd love to take a look. It's, you know, I applaud this sort of work. It's what we should be doing. So thank you. Stay safe. Until the next time. Take care. Goodbye.